In the previous videos, I have explained how to add and configure BGP during concrete cluster, locator pool, and VRFs, and how the traffic is forwarded then according to these definitions, and as well as along with the eBPF map state. Let's review right now entire setup. Again, right now is fully configured. So quickly, what are the components? 4 nodes, each node has its own IPv4 CIDR and IPv6 CIDR. One of them is SRv6 responder. Set of pods deployed on the cluster. Some of them there are like infrastructure pods, some of them are user applications. Subset of them are configured via the annotation label or metadata label to be part of VRF1 orange or VRF2 green one. We also have BGP from Q perspective. BGP peering created IPv6 address family advertised to an upstream Tor, VPN address family advertised to a route reflector. Locator pool is defined and then from that locator pool, every node in the cluster gets the locator with the common prefix and variable part after the prefix up to the 48 locator len bits. From this space, the seats will be advertised as soon as VRFs are created. We go to VRFs. We have 2 VRFs created. Both are associated with the same pool, so getting the final seat from the locator on every node, right? That was the locator on node number, or maybe that one, right? On control plane node, and we have the function, and ending up with the seat. The VRFs are configured with pod selection rules based on the label, and these are the pods which have that label in its metadata. And then also the forwarding rules are defined for these pods as part of the RF, that these pods can only communicate with this specific destination CIDRs, which belong to C11, C12, and on VRF2, C21 and C22. As a side effect from the functional perspective, when we go to Grafana dashboard, we see all the communication between the agents and reflectors up reporting some delay, so connectivity is there. Let's also take a look at the egress policy. The egress policy is defined, and that's defined automatically. That's the object you don't want to change yourself. It is defined based on the BGP advertisement, VPN advertisement from the route reflector, and as you will see, it contains the seat of the remote destination. So that's the C12, C11 seat, and so on, 21 and 22. That's the egress policy. So when the traffic forwarding happens and the pod in the VRF, for example, 1 sends the data to this destination, this seed is then used as the destination IPv6 address on the packet that encapsulates V4 packet. That's why it's called egress policy. And again, that's based on the VPN BGP advertisement. On the eBPF map level, we have all the maps populated. That one policy map is pretty much identical to the egress policy CRD. Then we also have the seed map. Every node has its own seed map. So it's one table, but keep in mind that it's different nodes will have different entries. So control plane node will have only these 2 entries. Worker 1 will have these 2 entries, and so on. And we have also that map is the same on every node, but we have the source IP address of the pod. That's something that I added to make it more readable, and the destination CIDR. So this way, combination of all of these maps dictate how packet forwarding works on the low level, on the low city level. Closing the review. The peering with Tor. The peering with Tor that's where we have advertisements of IPv6 address family. So we have the pod SRv6 as well as locator pool, and we have also, and then on this P5, these IPv6 networks are advertising to ISIS. So all the nodes in the topology will understand how to route to the locators pretty much. That's what we care about. They will also note about these routes, but we don't care about them in this use case. And on P6, that's where we have the peerings from cluster nodes as well as all the PE devices. On VPN v4 address family is enabled there. Every cluster node advertises over this VPN v4 its own node CIDR along with the proper route distinguisher and the function and the seat, pretty much the seat allocated per node from a node locator, right? So we see that the same common joint pod network on a control plane node is advertised twice in each VRF, and each one has its own seat or its own function within the same locator, right? Finally, if we go to C11 and we see what the C11 is learning over BGP, it learns not only the remote far end of C12 that belongs to Orange VRF, but also learns the IPv4 CIDRs of every node in the pod cluster, right? And if you go to P11, we will also see here that we have these IPv4 CIDRs of the clusters with the appropriate seat advertised. So P1 will know how to encapsulate the packet as an SRv6 header type of object, how to encapsulate the packet when C11 sends the data, for example, to a pod living on worker 2. Then it will be encapsulated with this seat ISIS routing, it will go to worker number 2. Worker number 2 will check its own eBPF map and check whether the SRv6 function is there. It will drop it, check the destination IPv4 address, pod is in the map, and the traffic will hit home. That's what happens when everything is configured correctly.